So in part A, we looked at when is the particle moving to the right. Particle's moving to the right when our velocity is positive. Part B is also asking about the direction that these particles are moving. So this is also a question about velocity. And this time it's asking the question about both particles. And so we've already done our sign chart in part A for particle R, so let's do it now for particle P. We're going to do P prime. So, derivative of this function. Derivative of 2 cosine of pi over 4t. Well, derivative of cosine here is negative sine. So 2 stays out in front there. So negative sine of pi over 4t which would not earn you credit for getting the derivative because it's missing the chain rule. Times derivative of the inside part. Derivative of pi over 4t is pi over 4. So looking at what's going on outside of the sign, we still have a negative. And then we have a 2 here and a pi over 4 here, which are going to cancel to be pi over 2. Times the sine of pi over 4t. All right, to start off our sign chart, we need to figure out where this is 0. So we need to determine what angle sine is 0 at. And sine is 0 at 0. Sine is 0 at pi. Sine is 0 at 2 pi. So we want what is inside of here to be 0, pi, 2 pi, 3 pi, so on. Okay? So what will make the thing inside of here 0? Well, 0. What will make the thing inside here pi? 4. What will make the thing inside here 2 pi? 8. Now I'm going to stop there because we're looking from 0 to 6. So I actually don't care about 8. It's not between 0 and 6. So 0 and 4. Zero, here is 6. Here is 4. We want to know when this is positive and when this is negative. So let's see. A point between 0 and 4. Let's pick 1. If I put a 1 in here, I'm looking for the sine of pi over 4. That's positive. sign is positive in that first quadrant, times a negative pi over 2 is going to make it negative. Between 4 and 6, now we're past pi and into the third quadrant, so now sign is negative. So this part is negative times a negative is a positive. So now what we are looking for, I've done the sign chart for you of when P is moving to the left and P is moving to the right. So now what we're looking for, when do the particles travel in opposite directions? There are two different ways that can happen. That can happen if one of them is moving to the right and the other one is moving to the left. Or it can happen when one of them is moving to the left and the other one is moving to the right. And so that I will leave you to finish and answer the question. Now that you got the sign charts in front of you, you should be able to see where those happen. Or if in any of those cases, if they don't happen at all. And so it should be at this time or in this interval. This one's moving to the right, this one's moving to the left, so they're moving in opposite directions. Questions so far? All right. Finding acceleration at 3. So find the acceleration of particle P at time t equals 3. Well, here's the first derivative, but for acceleration, I want the second derivative. Derivative sine is cosine.
Chain rule.
It's coming again. It's the chain rule. Times derivative of the inside part. Derivative of pi over 4t is pi over 4. So that equals, we got a pi squared over 8. It's negative. Times the cosine of pi over 4t. So now we're going to plug in 3 for t to get our acceleration here at 3. That puts us at 3 pi over 4. That's the second quadrant. So cosine is negative and root 2 over 2. So this will be, to finish us off here, negative times a negative is a positive. Pi squared root 2 over 16. any questions up to that point. So that is our doing the calculations, doing the derivative, kind of the more mechanics side of things. Now here comes a concept question. All right? So have the pencils down. Stay away from talking about this specific example. We're going to talk in general about what acceleration is telling us. All right? Think about acceleration as a force that is moving you in a particular direction. Because what we're going to ask now is, are we speeding up or are we slowing down? And that is not just a question of, is acceleration positive or negative? That's not the question that's being asked. It is asking, acceleration is a force. So this is asking, is the force that the acceleration is pushing me, is that force going in the same direction that I am moving? All right, so for example, let's say if acceleration here is positive, okay, that means that the force is pushing me towards the right. So if I am looking at this, if I'm traveling to the right and acceleration is pushing me towards the right, then I'm going to start to move faster because it's pushing me in that same direction. But if I were traveling off to the left and acceleration is pushing me towards the right, then I'm going to slow down because that's the direction that the force of acceleration is pushing on me. Right? I'm going to start to slow down, and eventually, since the acceleration is still pushing me towards the right, it's going to stop me and start driving me towards the right faster and faster and faster. So that is what it's happening. Another way to think about it. Acceleration due to gravity on Earth is negative 9.8 meters per second squared. That's the acceleration due to gravity. Notice that it's negative. Why? Because acceleration for gravity is pushing you in a downward direction. So A of t, where t is time, it is literally a constant function. It is just negative 9.8. It doesn't depend on any amount of time. So let's say that I'm throwing something into the air. It doesn't matter how long it's been since I threw the thing into the air. The acceleration due to gravity will stay the same throughout. Velocity is going to change, right? And that's, if I took the antiderivative, then I would get a function with time in it where the velocity is going to keep changing. So, if I am throwing something in the air, if you think about at different times and think about whether it's speeding up or slowing down, the answer is dependent on time. Even though acceleration is always negative, but the answer is dependent on time. If I am thinking in the instant that I'm starting to travel upward, it's going to start to be slowing down because it's traveling upward, but the acceleration to gravity is pushing it downwards. And then eventually it's going to cause it to stop in the air for an instant and then start to push it back downwards. And when it's getting pushed downwards, then the force of acceleration is going to push it in the same direction and start to speed it up because it's traveling downwards and the force of gravity is pushing it downwards. So, that is the concept behind the statement of we want to look at both velocity and acceleration to answer this question. We need to know if I'm asking, am I speeding up or slowing down? What I am asking is the force that is the direction that the force is pushing me in the same as the direction that I'm traveling? So, for particle P, let's look at if that's the case. The force is pushing me in a positive direction. So acceleration here is positive. A of t is greater than 0. Sorry, at 3. So we'll put a of 3. It's greater than 0. Velocity at 3, sorry, let me make this more precise. P double prime and P prime. Velocity at 3, well, we already talked about velocity at 3 because we made the sign chart and decided that velocity at 3 is negative. So we are going to say P is slowing down at t equals 3 because velocity and acceleration have opposite signs. You need to talk about both velocity and acceleration. The particle is, at that point, it is moving to the left, but it is being pushed by acceleration towards the right. So it will be slowing down. Any questions on that idea? I'm just going to give you a hint on part D. Right, but do not evaluate. Is the non-calculator part. It's not going to ask you to evaluate. Because that would add quite a bit more time to the problem if it asked you to evaluate it. An expression for the average distance between the two particles. So we are looking for average value of distance. Remember, average value of a function. We had a formula for this. I talked about it a couple chapters ago. average value of a function is 1 over b minus a times the integral from a to b of f of x dx. And in this case, we are looking for the average value of distance. So the question you have to ask yourself is, how would I find the distance between the two particles? And that's what is going to go inside the integral. What's a and b? A and b are my endpoints. So in that case, it's asking for between 1 and 3. So it's asking for average value of a function. That's our formula for average value. So I haven't done the entire problem, but I've done a lot of the outline of how the problem's going to work. And I did parts B and C. So that should give you some good ideas here.